Okay, so today we're looking at quadratics. We're just going to look at some characteristics of the equation, the graph, the tables of a quadratic, and just kind of talk about the things that happen. So this is the standard form for a quadratic. We have seen this before. Any equation with a degree of 2 is called a quadratic. Sometimes there might not be that middle term or the constant. It could just be as simple as the equation y equals x squared. So we're going to talk about the effect of a on a parabola. So that's what the graph of a quadratic is called, parabola. And so we're looking at that number that's with the x squared term. So we have two examples here, one where a is 1, and then the other where a is -1. And the graphs do wind up looking pretty opposites of each other. When a is positive, so it could be 1 or 2 or really anything, the parabola will open up. It will create almost like a smiley face, and we call this concave up. If a is negative, the parabola opens down, and we'll call this concave down. The vertex of the parabola is the lowest point when it is opening upwards, and the highest point when it is opening downwards. A lot of times we'll also call this the minimum point, and this one the maximum point. Okay, something else that happens with parabolas and quadratics is that they are symmetric. So they can have a line that goes directly down the middle and be exactly the same on either side of that line. So in this case, the axis of symmetry right here is the line x equals 2. And that also happens to be the x value of our vertex. If I look here, the line for the axis of symmetry is x equals -2, which is also the x value of our vertex. The y-intercept of our graphs, we have seen this before. It's just important to remember that these are an ordered pair, so to write it as though. And this can also be found really easily in your equation by looking at the c value. Domain and range. So again, remember domain is how far left and how far right our graph is going to go. And then range is how low to how high. I did add some arrows here because they're supposed to have arrows, so that's why it looks a little funky. So if I look at my first example, the domain, the arrows are showing that they're going to go on forever in both directions and keep getting wider and wider. So the domain is -infinity to infinity. And then the range is going from the lowest point, which is -3, to infinity. And we are touching -3, so that's why we have that square bracket there. And that is also the y value of our vertex. For our next one, same thing. Domain is going to be all real numbers, -infinity to infinity. And our range, it's going really, really, really low, and then it's going to stop at 4. So again, we are touching 4. That's why we have that square bracket, which is also the y value of the vertex. Okay, so we're just going to analyze this quadratic function, the equation of it, the table, and the graph. Okay, so we want to know, is it concave up or is it concave down? So I can see from the graph that it does have the lowest point and it's opening up to the sky like a smiley face. I also see that my a in my equation is positive, so it should be concave up. Does it have a minimum or a maximum point? So again, it's concave up, so that means it's going to have a low point, so it should have a minimum. The y-intercept, there's 3 different places that we can find it. We can find it on the graph, we can find it on the table, and we can find it in the equation, right? That c, that 1. The vertex I can see in my graph right here, that's the turning point, it winds up being -2, -3. I can also see on my table that at that point, -2, -3, if I look at every number above that point and every number up below that point, that's where it starts to be symmetric. So that's how you could see the vertex from your table. The axis of symmetry is that line that goes through the vertex, that vertical line. And it is that x value of your vertex from your table as well. Our domain is still -infinity to infinity. It has those arrows out here. And my range is going to take that y value from the vertex and go on forever. Okay, so there is a way that we can algebraically determine the vertex if we don't have the graph or the table. So we can find the vertex by using this formula, x equals -b over 2a, and that's going to give us the x value of our vertex, which is the axis of symmetry. And then we can use that to find the corresponding y. So we have this equation here, and we want to find our vertex. So first, let's identify what a, b, and c are in this equation. We're going to substitute those in, so I'll have -4 over 2 times -1. When we simplify that, we have -4 over -2, which just gives us 2. So that is the x value of the vertex. We can take that and replace it for x into the equation to find y. So when I do that, we will replace the x with 2 and in both cases. When I simplify, we will have -4 plus 8 minus 2. And so that will give us 2 again. So that means that our vertex is 2, 2. When we're going to graph a quadratic function, it's really very similar to how we would graph any function. We're going to create a table of values. It's just a matter of where we want to start with that table. So we start with the vertex. So let's find our a, b, and c and plug it into this formula to find our vertex. So I will have -6 over 2 times 1, which will give me the x value of my vertex is -3. Plug it right back in there. We should have a squared here. So we could have 9 minus 18 plus 8. And that will give us -1. So my vertex is -3, -1. Okay, that is our starting point. We're going to fill in our table of values from choosing x values to the right and left of that vertex. So again, quadratics are cool because they're symmetric. So whatever I get for these two boxes above the -3, they're also going to be the same y values for the two boxes below the -3. So let's test -2. When I substitute -2 for x back into the equation, we get the point 0. So that means that the next point below -3 will also be the point -4, 0. Let's try with -1. When I substitute -1 in for x into the equation, we wind up with 3, which also means that when I use -5, I will also get 3. I'm going to let you guys plot those points on your graph. Make sure that you connect them with a nice curve, and don't forget those arrows on top.